All right, so let's take a look at our practice test. We're going to take you through the key. Number 1, state the Pythagorean theorem. Now these two need to be very specific. We're very precise with our words, so definitely copy down what I have here. If you have any variation, it can't be too much different. I know online there are a couple different things you might see, so I'll, be reasonable. But what we're looking for stating the Pythagorean theorem in a right triangle, the sum of the squares of the legs equal the sum, not the sum, I say this every time, the square of the hypotenuse. So in a right triangle, so some of the important key words: right triangle, sum of the squares of the legs equal square of the hypotenuse. Okay, I understand that looks horrendous. Sorry about that, guys. Let's go ahead and start over here. All right, hi, we're going to go through the key of our practice test for Unit 10 Pythagorean Theorem. Numbers 1 and 2, there's very precise language that you need to put in these answers. There are a few variations, but basically this is what we're looking for. So for the Pythagorean theorem, in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. Now the variation that you might get would be, you could possibly say, in a right triangle, the square of the hypotenuse equals the sum of the squares of the legs. Okay, what we're not looking for is for you to write a summary or a description. We don't want you to say, if you take this, if you square each leg and you add them together, that's not mathematical enough. That's more of a, in your own words, description. A theorem is very specific words that you need to use. Now, what's going to happen is I wanted you to state the converse of the Pythagorean theorem. And that's basically the reverse. What's happening in number 1 is, in number 1 we're saying, in a right triangle, what's going to happen is a squared plus b squared equals c squared. So we're starting with this. This is point number 1. We're saying if it's a right triangle, then a squared plus b squared equals c squared. For the converse, what we want to say is, we want to say if a squared plus b squared equals c squared, then we're dealing with a right triangle. Okay, so these are in reverse. Pythagorean theorem is, if you have the right triangle, then this happens. Converse, if you have all the sides and the math works out, then yes, it's a right triangle. Okay, so it's kind of like two different things we're looking for. In Pythagorean theorem, we're looking for a missing side. In the converse, we're trying to determine if this triangle is a right triangle. Okay, these examples here do not constitute the theorem. That was just a little side note for you. So let me get you some verbiage here. If the sum of the squares of the legs, of a triangle equal the square of the hypotenuse then it is a right triangle. So basically, it's the same thing in the different order. Okay, here we start with in a right triangle. Here we end with the right triangle. All right. So pause here and get those copied if you need to. And let's take a look at our next three problems. Number 3, find the unknown length. Write your answer in simplest form. Show your work. So my right angle is where my A and B are attached. C is across from my right angle. So I get 9 squared plus 12 squared equals C squared. 81 plus 144 equals C squared. This ends up being 125. Nope, 225. Use a calculator. Let's try this again. 225 equals C squared. Square root each side, and you get 15 equals C. There's your answer. Each of these steps will be required. Do not skimp on the steps. Number 4, find the length of the side. Now they even tell you A is here. Now I'm going to say that's B and that's C. Remember, C is across from the right angle. B and A are attached. So I have A squared plus 15 squared equals 17 squared. A plus 225 equals, sorry, that's my cat. 17 squared is 289. Start solving our equation. Oops. Again, do not skip these steps. I understand that you're going to have a calculator, but I want to see what's happening. Because on a test, if you make an error and you did all this stuff on the calculator, I can't tell what the issue is, and I can't decide if what you did isn't so bad that you can still get some points. So now we need the square root of 34, which is about 5.8. And what's my problem here? Hmm. 5.8 isn't an option. All right, very interesting. I'll have to go see what the issue is with that and what they say on the key. But A equals 5.8. All right, number 5. Bottom of a ladder placed 4 feet from the side of a building. Top of the ladder must be 13 feet off the ground. So here's my building. Pretend that that's straight. And here's my ground. So this is 4 feet because here's the bottom of my ladder. Here's the top of my ladder. So there's my ladder, there's my building. This right here is the ground. Okay, so you can imagine the ladder here. It's got to be at least 13 feet above the ground, or off the ground. And it's 4 feet here. Okay, so this is creating a right angle. So I need to see the shortest ladder that I can buy. So we'll say 4 squared plus 13 squared equals C squared. 16 plus 169 equals C squared. 185 equals C squared. Square root each side. And what we get, square root of 185 equals 13.6. Now, remember our question here. What is the shortest ladder that will do the job? Now, imagine this for a second. This ladder right here, if it has to be exactly 13 feet, the ladder would be 13.6 feet. Problem is you can't buy a ladder that way. It's either going to be a 13-foot ladder or a 14-foot ladder. Now, if this ladder is any shorter, it's going to go down lower. If it's down lower, it's not going to be 13 feet off the ground. That's a problem. So in this case, we're going to round up. And our answer is B, 14. Let's look at our next page. Focus on 6, and then we'll scroll down to 7. Find the length of AB. So our first step, oh goodness. Our first step is to create a right triangle and measure our side lengths. My side length here is 3 and my side length here is 3, and I need to know what the distance is, which is going to be C. So 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. 18 equals C squared. Now something happens here that we've not talked about. You're going to see a little box pop up on the side that if you click on, it will open a new window with video that will help you with what I'm about to do if it doesn't make sense or if you want to see more practice. But if we look over here at my choices, none of these say square root of 18. However, we have this little guy right here. Be careful. They're going to know that you get 18, and they're going to see who's not going to pay attention and who's going to cut corners and who's not going to focus and who's going to pick C. If you pick C, I know you're not focusing. Okay? Stop and think. This is square root of 18. 18 and square root of 18 are not the same thing. Look over at my line here from A to B. I know I've told you can't trust the unit measurements here, but I mean, really, is there any way that's 18? There's no way that's 18. I couldn't tell you what it is, but it's got to be something around 3, 4, 5, something like that. Okay, definitely not 18, so be careful. Here's the deal. One thing that you may have to do is you may have to simplify a square root. And here's what I mean. You might have to look at the number that's in my square root and see if there's a factor that's a perfect square. So look for a perfect square factor of 18. Think about the numbers that multiply to make 18. Can you find two factors where one of them is a perfect square? I can. 9 times 2. 9 times 2 equals 18, and 9 is perfect, isn't it? So what I could actually do is I could actually write this as 9 times 2, which actually becomes square root of 9 times square root of 2. Square root of 9 is 3. Can't do anything with the square root of 2. I end up with D. Now when we did square roots, we skipped this part when I had to narrow things down. If this makes complete sense to you, sweet, move on to number 7. If it does not, then click the button that you're going to see pop up in just a second, and it will open up another tab with a video that shows this. Your question number 6, more than likely you'll have to do this. All right, let's take a look at number 7. Now, number 7 is crazy, all right? And actually, we're going to come back to 7. Let's go look at 8 first. I'm going to stall on doing number 7. Okay, number 8. Triangle SUN has side lengths of 5, 6, and 7 units. Determine whether it's a right triangle. Show all of your work. Okay, so let's use our, let me draw a line here. Let's use our little grid marks here. So one side is 5. Oops. One side is 6. And my longest side is 7. Awesome. 5, 6, 7. Remember, our longest side is always here. This could be a right angle. I'm not sure. I'm going to put the 7 as the longest side. So what we want to do is we're looking at the converse. So is 5 squared plus 6 squared equal to 7 squared? Now what you might have noticed on your lesson video is they left out the equal sign, and that's just because we didn't know if it was equal. You can't just put a plain old equal there because we don't know right now. I'm not sure. So I'm not going to say, oh yeah, that's definitely equal. That's why what I do is I put a question mark here. It's up to you. You could leave it blank and just put a question mark in between. So 25 plus 36 might equal 49. 25 plus 36 is 61. Now in your work, I'm expecting to see a slash through that those are not equal. So I need you to identify that they are not equal. The other thing you have to do is you have to say not a right triangle. If you just do this work here, if this is all you do, you are not getting the points. Yeah, algebraically, you came up and you see that 61 does not equal 49. But do you know what that means? Do you know that that tells you there's not a right triangle happening? So I need to see this is very important. When it says determine whether it's a right triangle, that's what you're doing here. You're telling me if it is or not. Show all the necessary work is this part. Both need to happen. All right, let's tackle number 9 or number 7. Let me get zoomed here. Okay, you have a rectangular box with dimensions 9 by 12 by 8. What is the length of the longest rod that will fit in this rectangular prism? This is a two-step question. Okay. This rod up here, I'm going to make it red. Not yellow, let's do red. Okay. Here's the deal with that. This rod is actually creates a triangle right here. Now with this problem, we're not doing a specific set of it. You are going to see a little box pop up in just a second that gives you more of these examples. But what we have here is I don't know, this is my C, the rod. My height here is 8. The reason that's 8 is because this is 8. This length down here, I don't know what that is. That's the diagonal of my base. Okay, and I'm going to call that x. So to get C, I would say x squared plus 8 squared equals c squared. The only problem is if I need two sides to figure out the third. I can't have two missing ones. It doesn't work that way. So I need to do something first. I need to do something to find out x. If I can find x, then I can find c. So what I want you to take a look at is take a look at this triangle that's created right here. Look at my blue triangle. Because it's three-dimensional, it's hard to tell, but this is actually a right angle. On a rectangular prism, all the corners create right angles. So I actually have a triangle right here. This triangle is 9 squared plus 12 squared is going to give me x squared. So my x is actually the hypotenuse of this base triangle. If I can get x in this equation, I can substitute it over here and figure out c. So let's see what happens. 81 plus 144 equals x squared. I get 225 equals x squared. X equals 15. So my base, the triangle, the diagonal on my base gives me x equals 15. So I'm going to take that 15 and I'm going to substitute it in, and I get 15 squared plus 8 squared equals c squared. 225 plus 64 equals c squared. Let me pull up my calculator. 225 plus 64 equals 289. Get the square root, and I have c equals 17. And that's it. Again, if you need more help with this is a big one. This is crazy. There's a link you can click on that will help you with these type of problems. And that's it.